Hello, in this video we will use SERIESSUM and LINEST in the polynomial regression of a Taylor series expansion, also known as Maclaurin series expansion of inverse hyperbolic tangent. Here we'll generate a dataset from the inverse hyperbolic tangent where our x values ranges from negative zero point 0.8 to positive zero point 0.8. So we have our formula, ATANH h of the x values. And we will chart this and choose a suitable trend line. So we will need a trend line that fits all the points of the dataset. We cannot use the linear because some points are not in the line. We cannot use the exponential because these points are not in the line. Let's try logarithmic. It's even worse. Let's try power series. Only half of the trend line. Only half of the dataset. Moving average. Oh, it's way out. Okay, we'll try the polynomial. And in polynomial, you can improve this by increasing the polynomial degree to 3. And let's see the r squared. Oh, the r squared is perfect 1. So it's polynomial to the degree 3. So our polynomial equation to regress this dataset, the ATANH dataset, is y equals 0 plus 0.936x plus 0x squared plus 0.673x cubed. The value for B0 is 0. B1 is 0.936, B2 is 0, and B3 is 0.673. We'll calculate these values using LINEST. To do that, we will need the x1, x to the power 1, x to the power 2, and x to the cube column because of this. Because we are the third degree of polynomial. So we start with the x column, which is our formula of the x values raised to the power 1. And then followed by the x squared column of the x values raised to the power 2. And the x cubed column of the x values raised to the power 3. Now we can enter the LINEST. So we enter the LINEST data y and data x. So our B0 is 0. Our B1 is 0.9364888, rounded up as 0.936. Our B2 is 0. Our B3 is 0.672666, rounded up as 0.673. Now that we have calculated the arctangent, the function itself, now we go to the expansion. So we'll need the n values from 0 to 8. 1, 2, 3. So these are the n values. We will also need the 1 over 2 n values. So this is the 1 over 2 n values. So it is 2n plus 1. So RA formula, 1 over 2 times n plus 1. That's our fraction of the coefficients. So that is a fraction. Next, we now use the series sum. So RA formula, series sum of the x values raised to the power 2n plus 1. 2 times 0 plus 1, that's 1. So raised to the power 1, incremented by, so we start with 1, 3, 5, 7. So it's incremented by 2. And the coefficients, this is the missing part or the remaining part of the coefficients. So you will notice these values are almost the same. They are almost the same. the expansion and the actual value, the function are the same. So we will insert this in the chart. So this range, and we show the trend line. So trend line raised polynomial raised to the power 3. We'll even show the r squared. The blue datasets are covered now because the red and the blue are the same. Let's go by the coefficients. Here B0 is also B0. Our B1 0.938 and the blue one is 0.936. Our B2 is 0. They're about 0. Our B3 0.677, 0.667. This one is 0.673. We'll calculate these values using LINEST. So LINEST data y, this time we use the expansion, and data x. So our B0 is 0. Our B1 is 0.9378. No, rounded up as 0.938. Our B2 is 0. Our B3 is 0.66728. Rounded up as 0.667. So this completes the use of series sum and LINEST in the polynomial regression of a Taylor series expansion of inverse hyperbolic tangent.